All right, Professor Jim Schultz here from my Finance 512 class. I wanted to go ahead and kind of wrap up this Chapter 10 and 11 material with a video going through a duration problem and going through an accrued interest problem. And so I'm going to go ahead and walk through the solution for each one of those problems based on the practice problems that I know you guys are working on. So let's go ahead and get started. So I'm going to do the duration problem first. And this problem is from the duration 1 practice set that I sent you guys. Alright, when you calculate duration, you're going to, as you read through the text, you're going to see the equation for duration. Well, what I do in my solutions is I essentially work out how that equation breaks down in a step-by-step process. And so if you kind of set up a table with each column, it allows you to very easily calculate the duration for a bond. And so essentially what you want are 5 columns in your table. The first column is going to be the time until the next cash flow occurs. The next column is going to be that cash flow. The next column is going to be the present value of that cash flow. The next column measures the weight of that cash flow relative to all the cash flows you receive. And then the final column is the weighted time of that cash flow. You might remember when I went through the duration video, I talked about how duration measures how important each cash flow is in the life of a bond. It's essentially what this final column takes into account. The importance of that cash flow in terms of both its amount and when it occurs. So let's go ahead and walk through each column. So for this problem, you have a 4-year bond that pays a 6.5% semi-annual coupon. Now, you guys have already learned from your previous classes that that means that it pays $65 a year, but that's split up into 6-month payments. So it's going to be $32.50 every 6 months. So that means for the first $32.50 payment is coming 1/2 of a year from today. It's always best to keep your time increments in an annual way, or in annual increments. And so that's why I have this represented 6 months as half a year, a full year, 1.5 years, and so on and so forth. And as you see, the cash flows are simply all the coupon payments you receive over the life of the bond, and then obviously at the very end you get your final coupon payment, but you also are returned the principal for that bond, or its par value. The next column is going to be measuring the present value of each one of these cash flows. And so essentially in each one of these numerators you simply see the cash flow that was in the previous column. Now you might remember from just basic time value of money stuff, the present value of something is equal to its future value divided by 1 plus I raised to the nth power. And so that is the equation that you see me use over and over again right here, where I is the yield to maturity on the bond. Now, the yield to maturity is 7.45, but because our cash flows are on semi-annual increments, we must discount those cash flows on semi-annual increments. And so that's why you see in this denominator, the 1 plus I is 1 plus half of this yield to maturity. Because this yield to maturity is an annual number, so to get it into semi-annual terms, I simply have to take half of that 7.45%. So that's 3.73%. So that's why you see 1.0373 repeated in this denominator. And then obviously the ends here are going to be the number of semi-annual periods that you have to go back to get back to the start. So this is obviously 1, that's 2, because we're in the first year. There are 2 semi-annual periods when you're in the first year. You're 1.5 years away, that's 3 semi-annual periods, and so on and so forth. And so here are all your present values of each cash flow. The sum of those present values is $967.32. That is the bond's price, because remember, a bond's price is nothing more than the present value of all its future cash flows. And so that's what this column is right here. Now, to find, in the next column, to find the weight of each cash flow, you simply take its present value divided by its price. And so these are all the weights that correspond to each cash flow. And then finally, the weighted time column is you simply take column 1 times column 4, and that gives you the weighted time. And once you have all those filled in, you simply take the sum of this final column, and that is your duration. So the duration of this bond would be 3.58 years. And so that's it. That's how you set up a duration problem, and that's how you calculate the duration for any bond that I would give you. So I want to go ahead and roll into this accrued interest problem that I also have. So the next problem I want to go through here is this accrued interest problem on one of the practice sets that I sent you. And if you remember, what is accrued interest? Accrued interest basically represents the interest that I am owed as a bond holder for the period of time that I held the bond in a given coupon period's window of time before I sell the bond. Right? Now that is probably a mouthful for you, so you might have to rewind that and listen to it again. But that's essentially what it measures. And you guys should be up to speed on that based on the accrued interest video that I gave, or that I completed. So this bond, we have a 4.5% coupon bond. It was just sold at a quote of 97.62. Remember, a bond's quote is always given as a percentage of par. And so to find the bond's price, you simply take 97.62% of 1,000, which comes out to be $976.20, which we will see later on. The current date is 4/11, and the coupons for this bond are paid on 5/25 and 11/25. So what is the invoice price for this bond? Well, you need to figure out how many days did you hold this bond in the given coupon payment period. So since it's April 11th, as this timeline up here shows, the coupon payment period that you're in right now is November 25 to May 25. So you held it from November 25 all the way to April 11th. So you're owed the accrued interest for this period of time. So how many days was that exactly? Well, how many days are in this coupon period to begin with? You literally have to add up the days between November 25th, between May 25th and November 25th. Or in this case, I had it right the first time, it's going to be November 25th to May 25th. So there's 5 days left in November, 31 in December, 31 in January, 28 in February, 31 in March, 30 in April, and 25 in May. So there's 181 days total in this coupon payment period. The original owner owned the bond through April 11th. So he held it for the 5 days in November, all of December, all of January, all of February, all of March, and 11 days in April. That's 137 days. So he is owed 137 out of 181. That's the fraction that he is owed of the coupon payment of $22.50, which of course was found by taking the 4.5% coupon bond. That's $45 every year, which is going to be $22.50 every 6 months. So the accrued interest here is $17.03. So if we take the bond's price, which was $976.20 that I mentioned earlier, and we add the accrued interest, that gives us the invoice price for this bond of $993.23. So that is how you solve a very basic accrued interest problem. So I hope these tutorials were helpful for you guys, and I'm confident now that you could, with these basic structures, you could handle any duration or accrued interest problem that I might send your way.